So students, in this second video, I'll explain you about the meaning of fundamental theorem of arithmetic, because this theorem is completely based on prime and composites number. So that's why I explained you in the previous video about natural number, prime number, composite number. So let me begin with fundamental theorem of arithmetic. See, first of all, uh, theorem is nothing but theorem in maths, nothing but is a rule or a law which remains true always and for which there is a proven statement or there's a proof. So fundamental theorem of arithmetic also can be proved. It's a law or it's a rule of arithmetic about numbers. So let's see what this fundamental theorem of arithmetic says. Okay, let's see. Fundamental theorem of arithmetic states that or says that every composite number, as I showed you, these are composite numbers 4, 6, 8, 9, 10, 12, these are composite number. So every composite number can be expressed or can be written or can be factorized in proper term as a product of primes or prime numbers. Means every composite number can be expressed as the product of prime number, and this factorization or this expression is unique. That means what? For a particular composite number, there is a unique way of expressing it as a product of prime. Means two students, if I give same composite number, they will never get two different combination of prime numbers as a product. Both of them will get this, will get the same prime numbers, but only one difference there. But only one expression there. Let's read the complete line. Apart from the order in which the prime number occur, only the order doesn't matter. In which order they occur doesn't matter. Suppose I give to student A and student B two same composite number, same composite number. Then if I tell them to find the prime factorization or to apply fundamental theorem of arithmetic on those composite numbers, then they'll get prime numbers, but those prime numbers will be same for both the students. They'll not get different prime numbers. What prime numbers has got by student A, the same prime numbers will be uh, achieved by student B, but the order may be different. What order A got the prime numbers may be different from the order of the second student. Suppose if A got X, Y, Z, B also will get X, Y, Z prime numbers, but he may get Y first and then Z and then X, or he may get Z first, X and Y. So means what? All X and Y are present, but order may be different in which order they get. There is only exception. So this is the meaning of fundamental theorem of arithmetic. That means composite numbers can be expressed as the product of prime numbers. Means 4 can be expressed as the product of these prime number. 6 can be expressed as the product of any of this prime number. Any means a particular unique expression is there, but it should be prime number. Same way, all this composite number can be expressed as a product of some of these prime numbers. So the simple rule is called fundamental theorem of arithmetic. So let me give you some examples here. Example 1c, 4, which is a composite number. Let's check. 4 is the first composite number. See, 4 is a composite number. 4 is a composite number. Can you see, students? This 4 is a composite number. This 4, which is a composite number, can be expressed or factorized as a product of 2 and 2, where 2 is a prime number. Check. See, you have done this one, no? Used to say LCM. Actually, this is not LCM. This is called prime factorization. That means we are applying here fundamental theorem of arithmetic. See, we divide this 4 by 2. 2 2s are 4. Again, this 2 we divide by 2 only. 2 1s are 2 because they have a number. So you find that 4 therefore is equal to what? Product of 2 and 2. That means 4 is equal to 2 times 2. Yes, 2 into 4. So just look here. 4 is a composite number. And this composite number we have expressed as the product of two prime numbers. See, 2 is a prime and 2 is a prime. That means we have proved that fundamental theorem of arithmetic is applicable here. That means every composite number can be expressed as the product of prime numbers. See, this 2 is a prime number. Same here with 6. 6, you can see there is a composite number. See, 6 is a composite number because it has more than 2 factors. And this 6, which is a composite number, can be expressed or factorized as a product of 2 and 3, or 3 and 3 by 2, 2 by 3 or 3 by 2. See, look, 6, 2 to the 6, 3 1 to 3. I can begin with 3 also, 3 to the 6 and 2 1 to 2. So that means I can express the 6 as product of 2 and 3 or 3 and 2. That means what? 6 can be expressed as product of 2 and 3 or 3 and 2. That means what? 6 is a composite number. We express it as a product of 2 prime number because 2 and 3 are prime numbers. Yes, 2 into 3 equal to 6. The composite number is equal to product of primes. But one thing is that here I write 2 first and here I have written 3 first. Here 3 second and here 2 second. That is what? The order doesn't matter. Both are correct. So order doesn't matter. In this way also write, you can, in this way also you can write, but it's unique. For 6, you'll always get 1 2 and 1 3 as the prime numbers, as prime factors. Okay, so same thing for this last number, that is 156. Suppose I give you 156, which is a composite number. If you keep on writing like this, 156 also is here, so it's a composite number. And this composite number, as you do prime factorization here, see, 2 7s are 14, 2 is 16, 2 3 is 6, 2 9 is 18, and then 39. So we divide by 3, 3 and 3 is 9, so 13 13. So this is a prime factorization of 156. And 156, if you write, you get 2 into 2 into 3 into 13, 2 2 3 and 13, 2 2 times, 3 1 time, and 10 1 time. Or I can also write 2 first and then 3 and then 2 and 13. Or I can also write 3 first and then 2 and then 13 and this 2. Or I can also write 3 first and then 13 and then 2 and then 2. In any order you can write, but it should be unique. There must be 2 2s, 1 3 and 1 13. 2 2s, 1 3 and 1 13. 2 2s, 1 3 and 1 13. So in this way, we have understood that fundamental theorem of arithmetic is a very useful rule. Okay, especially it is used in the next exercise to come. Thank you.